Okay, this is the explanation of number 43 on the benchmark 4 review packet. Position at time t greater than or equal to 0 of a particle moving along the x-axis is, so here's the x-axis, here's 0 on the x-axis. I'm not going to draw on the y-axis, but you got a particle that's moving back and forth along here. All right? Its position is given by this equation. So s is the position, t is time. Time has to be greater than or equal to 0. So first question, what is the particle's initial position when t equals 0? So there's a couple ways you could do it. One way is you could just find s of 0 for part A. You could just plug 0 in for time. So 10 times the cosine of 0 plus pi force. So that's going to be 10 times the cosine of pi force, which if you think about your unit circle, pi force is right there. Coordinates are square root 2 over 2, square root 2 over 2. So the cosine is your second number, right, your y coordinate. So this is just going to be 10 times square root 2 over 2. And then you can take 10 divided by 2. So the answer would be 5 square root 2. That would be your initial position. Now as a decimal, let's just figure out what that would be. 5 square root of 2 is 7.071. That's its position. So it's 7 units to the right of 0 when it starts. It starts to the right of 0. Okay, it doesn't say that it's 7 meters, 7 feet, 7 inches, whatever, but it's 7 units to the right. Next question. When does the particle first reach the origin? So particle's moving around over here on the right. When does it first reach the origin? When does it first cross? The origin is right there at 0, 0, right there. When does it first get to that position? Well, that would be when the position is 0. So for that, I'm going to put 0 in for s. So I'm going to have 0 equals 10 cosine of t plus pi force. So at what time does the position equal 0? So the first question is, what's its position when time is 0? The second question is, at what time will the position be 0? So the way I'm going to do that is put this into my y equals, which I already have in here. Then I'm going to graph it. So I'm going to go to window. T has to be greater than or equal to 0. Let's just look at the time, at where the particle's at during the first, let's say, 2 seconds. So x min 0, x max of 2. And if I don't find a place where it crosses the x-axis, I'll have to redo this. But x scale of 1, I'm going to hit zoom 0. I'm going to look at the position of the graph during the first 2 seconds. So for example, if I hit trace 1, enter, what this means is after 1 second, the particle's at a position of negative 2.12. So the particle's over here to the left at negative 2 point something. Let's say after like 0.5 seconds, 0.5, enter. After 0.5 seconds, the particle's at 2.815. So it's over here on the right somewhere. So how do I know when the particle crosses that line right there? If up here means it's got a positive position, which means to the right of 0. Down here it's got a negative position, which means it's to the left of 0. Where would it actually cross the origin? Right here. Right there. The 0. We're going to figure out when this equation equals 0. When y equals 0, you push second trace, number 2 for 0, go a little bit left of the 0, push enter, a little bit to the right, enter, back where it crosses, enter, and there we go, 0.785 seconds. I guess, I don't even know if it says seconds, but t equals 0.785 would be the time. That's the time when it's going to cross the origin. That's when it's going to be right there. This is the origin right here. I don't have my y-axis drawn in, but you can imagine it there. Any questions on that? All right. The rest of B. What are its velocity, speed, and acceleration at this time? So I'm going to have to plug this time into some other equations. So what I'm going to suggest is that, first of all, you might want to write out the whole decimal, 39816. Because you don't want to plug a rounded number into an equation to find another answer. It'll throw that answer off. And I'm going to be pretty picky about how exact you are in your answers. Another thing you can do is you can store this in your calculator. If you hit second quit, and then the store button is right above your on button, it says STO, and let's store it in variable t. So I hit alpha t. So I went from I'm not storing this number, I'm storing the number that I was traced to. That will automatically be in your answer. Wherever I was, this number here is what's going to go in. So, there it is. Yep. So you can see t is equal to 0.785398, etc. Now I'm supposed to find the velocity, speed, and acceleration at that time. So I'm going to erase some of this so I have room to show it on camera. So this is the velocity equation. This is the position equation. The velocity equation would just be the derivative of this. So you copy down your 10. The derivative of cosine is negative sine. We'll put the negative up front. Chain rule says you copy down the inside stuff. Then you multiply by the derivative of this inside stuff. The derivative of t plus pi force would just be 1. Our acceleration equation would be the derivative of that. Copy down the negative 10. Derivative of sine is cosine. Copy down the t plus pi force times the derivative of t plus pi force. So those are my derivatives. Now I also could have made the calculator do the derivative. I could have, when I go to y equal, I could have pushed math 8 and made the calculator figure out the derivative of this. And if it was a more difficult equation, I probably would have done that. But since this wasn't that bad to do, I just did it by hand. So it's going to be negative 10 sine of x plus pi force. So x stands for time here. And then acceleration would be negative 10 cosine of x plus pi force. And let's find the velocity first. So I'm just going to turn off the first and third ones. Only looking at the velocity equation. I'm going to hit zoom 0. Really what I want to do, I want to plug that 0.78 time I had into the velocity equation. So the other thing I could do is I could just, on my home screen, just type negative 10 times the sine of t plus pi force. I'll show you that in a minute. If I hit trace and then alpha t, it'll trace to that point, and we can see my velocity is negative 10. The other way I could have done it, on my home screen, I just could have typed in negative 10 sine alpha t plus pi force. You see, we still get negative 10. So the velocity at that time, the velocity at, okay, I forgot, what was it, 0.78 something, right? 0.78? 5. Okay, and I'm not going to write it all out, but it comes out to negative 10. How about the speed? How do you find speed if you know velocity? All right, it's just the absolute value. So the absolute value of negative 10 would just be 10. So there's your velocity, there's your speed. For the acceleration, let's just type it in here. We can do it on a graph if we want, but I think it's probably almost easier just to type it in your calculator. So acceleration, I'm going to type in negative 10 cosine alpha t plus pi force. Now you don't have to store it in t, but it sure saves you a lot of work instead of having to retype that big long decimal every time. 0. So the acceleration at 0.785 at that time is 0. Normally I'd have you label them, but I don't think I didn't even give you any units to use to label. So that's part B. That's the rest of part B right here. Any questions about that? Okay, when does the particle switch directions for the first time? There's two ways to do this one. You can look at the original graph, which is what I'm going to do. I'm going to turn off the velocity acceleration graphs, look at the position graph, zoom 0 to fit the screen. I need to look, I need to make my X max bigger. So I can see, let's do a first 10 seconds, 0 to 10. Okay, I need to hit zoom 0 again to refit my screen. Zoom 0. So I hit trace, 0, enter. So now watch this. Right now, my particle's got a position of 7 units to the right of 0. As I make my time get bigger, which way is the particle moving right now? If it went from 7 down to 1. It was at 7, went down to 1, so it's moving left. So this, as it comes down, it's moving left. Now there it's at 0.4, negative 0.65, negative 1.7, negative 2.7. So it's still moving this way, still moving left. When do you think it's going to turn around and start moving to the right? Right at the bottom, right down here, yep. And I can't see, that number's covering it up. I'm going to change my window a little bit. Go to window. Let's make my Y-min a little bit smaller. Instead of negative 9.9, I'm going to go like negative 15. That gives me some empty space here. Let's find that minimum. Here the particle's moving left, right, left, right. So second trace, number 3 for minimum. Get a little bit left, push enter, a little bit right, push enter, and then right at the minimum, push enter. And it should give us the first time where the particles switch direction. So it switches direction at 2.356 seconds. That's the first act. It's not in seconds, I guess, but if it was, that's the time now, 2.356. So the answer, T equals 2.3. 5, 6, because the slope of the position graph changes signs. In other words, the slope went from negative to positive here. So that's the first time that it switches direction. Now, one little other way you could do this, and you don't necessarily have to do it this way, but I think we've talked about this in the past, so I want to make sure you see the connection here. If I would graph the velocity graph, and then hit like trace, 0.5, enter. Whoops, try that again. I'm graphing the velocity graph. Okay, I'm going to hit trace, 0.5, enter. This negative velocity would mean the particle's moving left. Let's say we go to like 0.7 seconds, 0.7, enter. Still has a negative velocity, still moving left. 1 second. Still has a negative velocity, still moving left. 3 seconds. But now it's got a positive velocity, so that would mean the particle's moving which way? Right, yep. So the fact that this velocity is positive 6, this is the velocity graph now, tells me that it's moving right. When the particle was down, or when my point was down here, it had a negative velocity. This is your velocity x moving left. So where would it be switching directions at? At the 0, yeah, you gotta find that 0. So there you have to go second trace, number 2. So I'm just showing you another way you could do it. Don't feel like you need to do it both ways, but. So this, if you're gonna, notice it's the same answer. But here your explanation, what you would say that the velocity changes from negative to positive, or your velocity changes signs. Would be how you'd explain it. And that's number 43.